Hey everybody, we are going to do a second example applying the difference quotient using the function in this screen right now saying f of x is x squared minus 3x minus 5. But before we can go ahead and actually use the difference quotient, which is down here, we got to make sure we can do a composition of functions correctly. So we're going to make sure we can do the f of x plus h properly. We have all our algebra nice and perfect so that we don't screw up. So let's go. So when we have to do f of x plus h, what we're going to do is we're going to look at every spot that has x in my function f of x equation, and we're going to swap it out and replace it with x plus h. So that means we're going to have x plus h quantity squared minus 3 times the quantity of x plus h minus 5. Now we can't just leave it the way it is. We have to fully expand, combine like terms. Well, there's not going to be any like terms, but later we're going to combine like terms and whatnot. So we want to get this all expanded properly. So what is the proper way to do that? Well, I'm not going to go into detail about this first part because I went over that in the last video. So we have x squared plus 2xh plus h squared. So that right there is going to be specifically, let's just, that's going to be that right there. The x squared became that, which became that. Okay, just to distinguish that right there. Okay, from there, we're going to keep going. Minus 3x. Keep distributing. Don't be a fool. Minus 3h and minus 5. So there we have it. So the f of x plus h is x squared plus 2x h plus h squared minus 3x minus 3h minus 5. So that right there, I'm going to color code, and that right there is going to be orange. And we're going to use that in part 2 or part B right down below. So that is going to be this part in my difference quotient. And I'm also going to need f of x, which is actually over here my original function, right? And then just one more time, that was this over there. Okay, so let's go ahead and start filling in everything for this. So our difference quotient, f of x plus h minus f of x all over h will equal x squared plus 2xh plus h squared minus 3x minus 3h minus 5 minus, oh boy, I'm just going to knock down this wall over here, make a little extra room, and sorry, just want to make sure I have enough space. Okay. So minus x squared minus 3x minus 5. Okay, sorry, I'm squeezing. And then that is all over h. Now, just to distinguish, this whole thing is the f of x plus h. Okay, and this guy right here is in here. Now, what we also want to make sure we're going to do right now is we need to make sure we properly distribute that negative. I don't know what students have against doing that, but something. So, showing every step, okay? X squared plus, you could double speed, fast forward, do what you got to do, okay? Plus 2x h plus h squared minus 3x minus 3h minus 5 minus x squared plus 3. Oops, wanted the square right. Sorry. Plus 5 all over h. Okay, so that's where we are right now. Now what's going to happen? Well, the x squared is going, when we clean this up, to cross out with x squared. What else is going to happen? Glad you asked. Everything from this pink part at the end is going to go away. So the plus 3x and the minus 3x are going to cross out as well. And then the minus 5 and the plus 5 are out of here. So what do I have left? What we have left is 2xh plus h squared minus 3h. That's it, right? I'm going to, while I write the next line, simultaneously factor out an h. So that means I have 2x, careful, plus h minus 3 all over h. Now, let's do... This h in the denominator, this h is a problem. Why is he a problem? Well, as mentioned before, he's the devil. Okay? Oops, don't move that. That h is a little devil. He's a problem child. We got to get rid of him. We need to get him out of the denominator because our future goal, our future plans for that h is that we want h to eventually equal 0. And as things are right now, he is absolutely not allowed to equal 0. However, I'm about to do something that'll solve this problem. And what is it? Well, I'm about to reduce, cross out, don't say cancel. Cancel makes 0. That makes 1. We're about to cross out or reduce or simplify that h over h down to a 1. Amazing. What's left behind for my difference quotient for this answer? Well, we are left with 2x plus h minus 3. Winner, winner, chicken dinner. But as promised, I'm going to take it one special step further. And if we were to be using the limit definition of a derivative, as explained in the intro, we want h to get as close to 0 as possible, and we can do direct substitution in this step right now. So I can fill in a 0 for that h, and my final answer will be 2x minus 3. And that right there, 2x minus 3, is the derivative of the original function f of x, which was x squared minus 3x minus 5. So there's your derivative. This over here is our difference quotient. This over here is the f of x plus h, and I hope all of that made you feel like an absolutely brilliant beast of a human being. So, thumbs up and try out another one. There's a bunch of classic examples on the playlist. Bye for now. Adios.